Dear students, welcome to the knowledge series. Under the course EC407 Computer Communication, we are going to discuss in the area of IPv4 numericals problems. We have gone through my previous video series where I have discussed about the networks layer. Under that class of a network layer, I have given an idea about classful addressings. So with respect to that one, we will have a brief discussions and continue with the rest of the sections related to the today's discussions. If you see across this particular slide, under the classful addressing, there are certain keywords like Internet Protocol address or a IP address. Basically, this internal protocol IP address is a numerical label that is assigned to various devices that is connected to the computer network. And this IP address is basically connected between the host to the network, and it also try to see that where this particular address is being located. Or in another word, I can say like this one, an IP address serves two main functions. One is host or a network interface identifications, and another is location addressings. So these two things is very important. You take an analogy of this one, just like your home. So where is that particular home, or in which place that particular home resides? That is one, and another is that what is the address of that home. So that's how, or we can say address of that house. Or in another word, these two things, one is the address and another is the locations, is very important in the computer networks. So with respect to that, we will be talking about it. Another area is we will be talking about IP subnetting, where a large IP network is divided into smaller IP networks. That is what we will be talking in the IP subnetting sections also. So let's see this particular slide, where you can see that a set of integers with a n is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, like that, it is being shown. Corresponding to that, the 8421 code, that is 2 to the power of n, it is being shown in terms of a 2 to the power of 0, 2 to the power of 1, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, up to 2 to the power of 8. So like that, different n value is being shown, and corresponding to that n value, the value of the 8421 code is being shown. Now here a figure is being shown with respect to the bits. You can see that this bits shows that the 32 bits is divided into 4 groups, that is 8 bits each. Now every 1 byte of the group is being shown over here, that is being a class. So that is, the class falls under the IPv4 addressings. So this is what we can see over here, that under the IPv4 addressings is that IPv4 consists of 4 numbers of a 1 byte groups, so which is having 8 bits each. So that's how the IPv4 is being defined. Now under this 32 bits grouping, we can further classify and as a class A, class B, class C, class D, and class E. Here what you have to understand is that in this particular form of classings, there are 2 sections is there. One is having a network ID, another is having a host ID. So one is talks about the address of that particular location, another is nothing but the device ID. So where that particular host ID is being resides. So that net ID and the host ID is being segregated into two part for the IP addressings. So in the IP case, if you look across the class A, the net ID is having a 1 byte, the remaining host ID is having a 3 bytes. In the class B, the net ID is 2 bytes, the host ID is 2 bytes. Class C, the net ID is equal to 3 bytes, host ID is 1 byte. Whereas for the class D and E, this particular section is not defined. So that's why we consider that the total as a multicast address, and this is being reserved. So that is what we see in the class C, D and the class C. To further understand this one, this is one particular form of addressing of IP addressing is further prepared so that it will give a very easy way of understanding, so that when you refer to the classful addressings, it will be an eye-catching for you. Now, when a class A addressing, if you are considering, here what is the size of the net ID? 1 byte, that is a 8-bit. So out of this 8-bit, 1 bit is kept aside to identify that it is a class A. Whenever you see the first bit on the net ID sections, the first bit, it is nothing but, or you can say that the MSB of these sections, that first bit is considered as a, if it is 1, then it is considered as a class A. So that's why, sorry, if it is 0, it is considered as a class A. So that's why you can see this one, the bit is being defined as a 0 here. So if 1 bit is kept aside, then the remaining out of 8, the 7 bit remains here. So that is what been shown in the green shades. So that is the 7 bits is here. It may be ranging from a 0 or a 1 combinations. Now, if you convert that binary 7 bits into a decimal 7, and if you try to see what are the different combinations is possible with 7 bits, so you will find that for a 2 to the power of 7 is 128. That means you will have a 1828 addressing you can able to form under the class A situations. That means the total network addressings. So this is a network sections, this green shade. So the network addressing under the class A will have a 128 network addresses. On the other hand, if you try to see the remaining sections, the remaining section is a 24 bits. But here we try to define the remaining number of hosts. To define this number of hosts, we have to put under the one formula, that is 2 to the power of number of host bits minus 2. So that is 2 to the power of 24 minus 2. So that is coming, that will appear as 7,214. So that is how that such a big host address you can able to get into the class A, whereas it is having a limiter network address. Now coming to the class B, you can see this one is a net ID and a host ID is equal. This is 2 by 2 byte. Now as you have understood this first scenario, here we have consisting of a 1 bit. Now in the second case, what we do is that from the MSB we take a 1 and 0 bit. So that 1 and 0 bit will be denoting the class B, and then the if you are taking a 2 bit out of the 2 byte. 2 byte means 16 bit. So your 14 bit is remaining here. Now out of this 14 bit, you again divide. You make one section as a full 1 byte and a remaining less than 1 byte. That means if you are dividing, so you can divide as a no, if you try to divide the 14 into 2 part, it is a 6 bit and 8 bit. So this 6 bit and 8 bit is same thing as a network ID. So this entire actually this entire section is a net ID, but in this one, in the real sense, it is only 14 bits, because 2 bit has taken only for the assigning for classification of which class. So it's a class B, that's why you have taken 10, that is a 2 bit out. So only 14 bit is there. Out of this 14 bit, you have kept 8 bit as a full bits of and the remaining 6 bit is being defined in the left side. So this 6 bit is indicating that you will be having a 2 to the power of 6, that is a 64 different possible addresses of a network is possible, plus this 255 is also there. But we are not mixing these two things together, we are keeping it aside. So this is a 64 is a 2 to the power of 64, and what is rest remaining, you will be having a rest for the remaining 8 bit is also existing in this one. But in a real sense, if you are if somebody asks you what is the total network addresses, then you have to put it as a 2 to the power of 14 addresses. But that is the actual answer. But here for easy and simplified way, it has been put as a 6 bit here and the remaining 8 bit here. So that from 2 to the power of 8 will show 255, here also 2 to the power of 8 255, 2 to the power of 8 255. The same was shown in the class A also. So here it was less than 8, so that's why it is 2 to the power of 7 becomes 2 to the 128. Here 2 to the power of 6 becomes 64. So this is the case with respect to the class B. So in class B, 14 bit is on one side. This is for your correction. This is not 14. This is a 16 bit. Okay, 16 bit is the corrections it has to incorporate in that particular sections. So the 16 bit here. So that's why it is a 8 and 8. Okay. Now coming to the class C. Class C sections, if you try to see, what is the size? It is 3 byte. That means it is 24 bits. 8 into 3, 24. So out of this 24 bits, 3 bit is taken aside for classifying the class C, and the remaining bit is here. 24 minus 3 is 21 bits. Again, this 21 bit is again splitted just like class B has pattern. Just like class B pattern. So here 8 plus 8 16 plus 5 21. So 5 is here and the remaining is been put here. So if you take that power of 2, that is 2 to the power of 5, you will get 32 bit here, 255 bit, 255, 255. So this is class C. Class D and class C is multi-classed address. So the total 28 bit is being taken. 4 bit is aside for defining class D, that is 1110. Class C 110, class B 10, class A it is 0. Now here when you are taking 4, how many bit is remaining? That is 4 bit. So because you are taking from these sections, out of this 8 bit you are taken 4 bits, so 4 bit is taken. So 2 to the power of 4 is 16 here. The same thing follows in the class E also, but only the difference is the class B, the classification set address is equal to 1111. So that's how, that is again a 4 bit. So here also you will be having a 2 to the power of 16. So that is the 16 possibilities you can see. But here we are not considering for that one, but you have to understand that this is totally reserved with respect to class D and class C. Now we why this one was prepared? This was specially prepared for you to understand the next slide, which I have already shown in my previous video series. So to understand that one, this one is very easy way of understanding. Here you only have to remember this is 7 bits, so 128 here. In class A 128, class B 64, class C 32, class D 16, and class E 16. So 128, 64, 32, 16, 16. So you have to remember like this: 128, 64, 32, 16, and 16. So that is what you have to remember in this way. That means here it is a 7-bit, 6-bit, 5-bit, 4-bit. So based on that, now we are going to the next slide. So here you try to see this slide. It was shown earlier also. So to understand that one, again here see, in this table class is shown, leading bit is shown, net ID is shown, host ID is shown, number of networks is there, address of the total number of the host address of the network is there, starting address and end address. So this is very important for you to understand, so that if any doubt is there, that will be clear. Now if you see the class A, the starting bit is what? 0. This you have agreed, because class A starting bit is 0, so that is 0 bit. B is 10, C is 110, D is 1110, and class E is 41. So this is clear to you, this one. Now coming to the net bits. So here what it has been put as a net bit is a total net bit, means the total size of net is 8, out of which 1 has gone here. So it becomes 7. That is the 7 you can see here. Okay, you just see this 7 here. Now coming to the class B, how many out of 2 bytes, that is a 16-bit that is been shown here, out of which 2 bit is taken. So 16 minus 2, 14. That is what you can see here, 14. Class C, how many? 3 bytes, so 24 bits. Out of 24 bits, 3 bit is taken out. So 24 minus 3, 21. That is what you can see here. It is 21 bits. Class D, how much? It is 4 bit. But here it is specified as a not defined. So no problem. You just consider as not defined. Class C also 4 bit, not defined. But we will be understanding this one how. So here class A starts from 0, because it is a starting class, starting addressing point, whether it is a decimal or a binary form, the starting point is class A. So it starts with 0, 0, 0, 0. This is a decimal form, a decimal and dot representations. Now it starts from 0, 0, 0. Up to what, how much it will, how many address it can able to occupy. That means every decimal is equal to 8 bit. So if you see this one, this 0 is the 4th location. So here you can see it is the 4th location, that is 1 byte. So this 1 byte is 8 bit. So 8 bit means 2 to the power of 8 is what? 256. So that is what it is represented as a 1 less, because it is starting from 0, that's why it is 255 shown. So 2 to the power of 8 is 256. So that is what I have shown as here. 2 to the power of 8 is 256. So here also 256, 256, 256. But here it is showing 127. Why it is showing 127? See here, 2 to the power of 7 is what? 128. So since it is starting from 0, we will put it as 127. That is why you see the what is the range difference from here to here. The network ID ranges between 0 to 127. That means it is having a 128 addresses between the first network to network. Now we go to the class B. If you see the class B, this is very clear. This is I have x 2 to the power of 7, this one 2 to the power of 14, this one 2 to the power of 16 is this one. That way it is being defined in these particular sections. Okay. Now coming to the class B, the starting address is what? After this is what? After you forget about that this is for the upper address. Okay, the next network address is what? 128. Now you may ask, sir, why it is 0000? Because you have to remember that this 128 is the starting point of this one. That means 128, it will go to the next higher address. So that is the important things we have to see, how much it has to go. And what is this one? That means under the class B, this particular place will be having its own bit. That is, again, it will be 8-bit, starting from 000 up to 8-bit, 8 zeros to 8 ones. So that is how it is consider in the form of a zero. It will start from 0 and it will go towards the 1. So you will be seeing the 255. That is what we can see here. Now here, when we try to see here, what is the class B? It is showing 64. After 128, the next class B range is for the one section is 64. Another section of 8 bits is going up to 255. That is if n is equal to 8. So here you start with 0 and you proceed, because if n is equal to 0 situations in this case, then it will producing 1, and it goes to the maximum, then it is going to become a 255. So here you start from 128 and it goes to 64. Why it is 64? Because the first bit is having a 64 addresses for n is equal to 6. So what is n? N is the number of bits. So in the first case, 128 plus 64, that is 192, minus 1, because you have to then only it is when you are putting in the form of a address writing, then you have to write, you cannot write 192 here. So because this is also already existing, so that's why it is 191 here. Now it starts from 0, it goes to 255. Now you see this one, it is initially it is having it start from 0 and it goes to 255. That means it start from 0 and it goes to 8-bit. So when it is a 8-bit, then it becomes a 256. That is 1 minus, that is 255. That is what we see here, 255. Similarly for this one, 255, this is for 255. So this is what we can see, the different possibilities of this one. Now here when you are putting 0, okay, then there is only one address. When you are putting 1, 2 to the power of 1, 2, that means 1 0. Here if you are putting 2, that means there are 2 bits, say 0 0 0 1 1 0 1 1. So that was 4 address. 3 bits, say 0 0 0, like that up to 1 1 1, that is 8-bit. Similarly here also 0 0 0 0. So like that you will be having a 256 combination, different combinations you can able to prepare. So that is what we should. So here how much you added? 64. So here to here it is 64. But if you measure from here to here, 197 to this one, this is also, it is appearing with respect to the 64 difference. So here this difference and this difference is also, it is going to reflect in the similar fashions. Now here if you add 64 directly, it is come, but here if you cannot add directly because it is already existing. So here it will appear as a 63, but actually since we are taking this one into consideration, that's why it is 64. Now coming to the class C, you see this one, class C, let us go. What is the maximum bit size? 30, maximum possible addresses 32. So you can see next bit is what? 192. 192 plus 32 is 224. So 1 minus, so it is 223. Now here also if you try to add 32, you will be seeing that it is 223. So this one. Class D, you see this one, class D, how many? 16 possibility. So you write 224 here plus 16. it is 240 minus 1, so 239. Similarly, others you write. Class E, again 16 possibles. So here again you add 16 by writing 240, the next starting address, 256 minus 1, so 255. So class E, at the class E you will be finding all the bits having a it has occupied the fullest, that is all the bits are 1 under the class class E scenario. So that is what you can see in this particular scenario of A, B, C and D, the different combinations of the possibilities being shown. So this is what means class full addressing and how this value is coming. Because straightforward to understand this one, find it difficult. That's why this was prepared for your easy understanding. Now we go to the next sections about network and broadcast. See, in a network there are two special type of addressings. So one is a network address, another is a broadcast address. Network address, basically it represents the network itself. That means say for example you are living in your colony, you will be having a different lanes. So if you are going to let us take a colony, there will be lane 1, lane 2, lane 3. So those are nothing but your network address. And broadcast address is that one, in which it basically the broadcast address represent all the whole host which belongs to it. So if from that host it will be communicating to every other host. Just like you are getting a message from the college with respect to any academic related. So the college is one host which is broadcasting that information to your host, that is your device ID. So that is known as a broadcast address. So that is one which is broadcasting to the all other hosts. It is considered as a broadcast address. Now there is a third is known as a valid host address. See, all address belongs to network address and broadcast address. Or we can say the address which is belong to network address and broadcast address is also known as a valid host address. And this valid host address is assigned to the device in a network, because host the endpoint where your device is going to assign, that is considered as a valid host address. And what are those devices? That includes for the end users, maybe the computer, laptop, tablet, your smartphones, your IP phones, or your server, printer, IP camera, terminals, or any network devices such as switches, router, firewall, proxy servers, and so. So all the devices which is connected to the host is should have a valid host address. Or in short, we can say that any devices that use the IP protocol for data transferring needs a valid host address. So along with the host address, there is another terminology you can see. It is nothing but a subnet. So what exactly the subnet? Actually it is going to divide the large IP network into smaller IP network, so that you can able to distribute to more number of the host to get associated to the the IP addresses. So that is the another sections with respect to this network and the broadcast address. This is the power of x. You can see the power of x keeps on increasing. So IPv4 is having the maximum address is up to 2 to the power of 32. That is what we see in the class D and the class E scenario. Whereas in the case of class IPv6, it is 128. So that's how you have to you have to remember with respect to the different IPv4 and IPv6 scenario, how that particular IPv4 and IPv6 tries to supports the different combinations of the network as well as the host addresses. Now we go to the next sections, mask. Subnet mask. What is meant by mask? We know that mask is something like something we put in front of our face, like nowadays because of the COVID situations, because of the coronavirus, we put a mask in front of our to protect our nose, mouth, thereby we keep away from such type of infected viruses. So that is known as mask. Another is network. Network is a combination of several number of nodes, devices, terminals. Sub means small. So we are doing a divisions of the network by using a mask. That's how you can consider. So subnet mask is basically it is to assign an individual bits for the IP addressings. So if the IP belongs to the network portions, then the subnet marks will be turned on. And if the IP belongs to the host portion, the assigned subnet marks will be turned off. That means you can see if you are creating a subnet here, if you are borrowing a 1 bit from here, then it is 1. If you are borrowing a bit from here, it is turned off or a 0. So that is what we try to indicate. Now as a IP address and a subnet marks, we normally use a decimal notations. That is what we see here. This is a decimal notations, and or we can use a binary notation. So this is a binary notations. You can see this is a decimal format. You can see. So here a particular decimal address is shown like a 10 10 10 10. So 10 10 is nothing but if you put it as 8421 code, so it is this and this bit. The fourth and the second bit should be high. So like that you can see these are the high bits. Now here we are using another decimal IPv4 addressing is IP addressing is 255.0.0.0. This is known as a masking. So what we are doing is that we are doing a network masking. So you can see this is 10 10 10 10. Now if this is IP address, if I ask you which IP is this one, how will you see? So the best way to see is that first you check the first address of first byte value. This shows 10. Now you go back to the slide here. 10 range, the range you should remember, 0 to 127 is belongs to class A, 128 to 191 is belongs to class B, 192 to 223 belongs to class C, 224 to 239 class D, 242 to 55 class A. Now if you may think, you can ask me, sir, how to remember this value? See, this side you can see all are 255. Similarly, if you see this side, all are zeros. That means the three groups on the right side, it is zeros. Three groups on the right side of the end address is 255s. That is easy to remember. Now you have to remember this one only. Now how will you remember? Just remember in your mind that four values: 128, 64, 32, 16, 16. Again I repeat, 128, 64, 32, 16, 16. So here you add 0 plus 128, so you got 128. 128 plus 64, you got it this one. Then 192 plus 32, you got this one. Then 224 plus 16, you got this one. See, from here to here 16 minus 32 minus 64 minus 128 minus. Very simple. This one you remember. If you remember this one, then you have to remember these values. So this is 128 means this is 127. This is 192, this 191. This is 224, this is 223. This is 240, this is 239. And here it is 255 last. You may ask, sir, how it is 255? Because the final bit is all should be ones. So this is how you should remember these values. So here this is coming between 0 to 128. So this is class A. Now you see this one, which class this one? This is 172. So it is the class B. It starts from 128 to 191. So 172 is coming between 128 and 191, which is class B. This is 192. That is class C starts from 192 to 223. So this is class C. So this class A is shown here, class B is shown here, class C here. Now what you have to remember is that the masking that you use, that mask value should be related to the first group or the first byte which is there. So so this is the first byte. You should remember this one. This is a network. This is so you don't go to this one because you remember you all the activities related to the first byte. So here if you do a masking, you should do a 255 here. The next is class B, then it is a 2 network. So that that's why here you have to do 255. Here mask 3 networks. So 255, 255, 255. So the masking is to mask the network. So for that, by doing that one, you try to find either the first address, starting address, or the end address, or the middle address, like that. You can see in the examples which I will show in these sections in the later part of the slide. Now here the same thing is being shown here. Exactly the what is shown. Network portion is in the form of a violet color, and the blue is nothing but a host portions. So you should remember, I repeat again, all the first byte you should consider, and for the class A, all the first and second byte you have to consider for the class B, all the first, second and third byte you should consider for the class C, and these are nothing but your network masking. That is known as a subnet masking. You see this one, this is a network, so that's why it is considered as a subnet masking. Now we go for the next is the subnetting eligible host bits. Now what does it mean by eligible host bit? To understand this one, again you try to see this one. In a class A, the first 8 bit, that is 8 bit is for network. Class B, the 16 bit is for network. Class C, 24 bit is for network. Now in a class A, if you are taking this one, so here the 24 bit is there. So out of this 24 bit, the last 2 bit is we are assigning for the host bit, reserved for the host, default reserved for the host bit, and subnetting eligible bits are up to this one. That means the 22 bits are eligible for the subnetting, the class A. Class B, if you try to see, out of the 16, the 14 bit is eligible for subnetting, 2 bits are for the default reserved for the host bit. And in the class C, you can see that out of 8 bit, 2 bit are kept for the host bit, reserved for the host bit, and the subnetting is done for the remaining bit. Now you may ask, sir, why it is repeatedly saying reserved for the host bit? This is nothing but it is one is a broadcast address. For that it is assigned, another with respect to the case related to the networking numbers. So with respect to that particular purpose these 2 bits is being assigned. That's why it is being kept in this particular order, default reserve host bit. Now we go to the next sections, subnetting directions. See, subnetting always flow in a single directions, that is from the left to right, and also taken into consider that there should not be any skipping of any bits. The simple rule for subnetting is left to right. That is what you can see, the directions. Now another thing is that say if you are considering a class C scenario, so if you see this one, this is a class C. How many bits? 24 bits. That is 3 bytes is occupied for the network, and the remaining 8 bits, 24 bits for the network and 8 bits for the host ID. So that is what we can see. Now here we cannot directly jump to this place and consider that this bit from here the subnetting should start. No, it will start from this place, 25, 26, 27, 28, 29, 30. So this is what you say as eligible subnetting host bit, and the remaining is a default reserved bit. If you are going from the right to left, it is a wrong way of representing the wrong way of defining or representing the selections of the subnetting bits. Now subnetting eligible bit, it start from 25, and from 25, 26, like that it will keep on going. But at any case after 25 it cannot go to 27. So that is the way the subnetting is being done. Now we see the slash notations. What is in by slash? When you see the IP address, it will be showing like this one. After that, one slash will be there. This one. So slash, basically slash notation is a compact way of representing the IPv4 subnet mask. So when you use a slash notations after writing the IP address, then and also the subnet mask number, so automatically this one will defines what is your network size, what is your subnet you are going to create. All this significance, it comes from here. Now if you take this one, this first one, what it look like? It's a class A. So if you take a class A, class B, class C, okay. So let's see this one. So if it is defined with respect to 8, that means this is a 8-bit with respect to the slash equivalent. So it is a compact way of defining the total number of bits in the subnet mask. So this is a 8-bit. So because you remember, masking where you are doing, it is for the network ID. So in the network you are using a 8-bit. So here 16-bit is for masking, 24-bit. Here comes 25 bits. See, now the changes is there. Now you may see 24-bit is coming because this is class C. Now here it is going to 25. Now you may surprise, for 25 here it is written 128. Because why it is gone for 128? Because this is the ID with respect to the host sections. So that is what you can see. Now let us see the case of a 8, first case. That is a 255.00 and /8. So here /8 is not shown. So let me take this one. This is a 32 /32. That means the whole this is a class E address. So the whole 32 is taken. So /32. So how many bits are borrowed from the host? No bits are borrowed, because this is a totally 32 bit which is being shown in the case with respect to the class C scenario. So that's why this has been represented in the form of a 32 bits representations. Now if you look to the 31 case, so it is going to borrow how many bits from the host 2 bit, 1 bit. So 1 bit means 2 to the power of 1, that is 2. So how many hosts will be there? There will be 2 hosts we can create. Now if you when you are going to create a 2 host, then you are it shows a suffix of a 254. That is what it is showing, the 254. Now here if you try to see the 30 means 32 minus 30 is 2, that is 2 bit you have borrowed. So that is what shown a 2 bit. 2 bit means what? 2 to the power of 2 is 4 host address you can able to create. That is what been shown. So that means whatever IP is there, that one will be having a suffix 252. Now coming to the 8, if you are taking 8 means what? You will be having a sorry, before we go to the 8, we are going to the 29 slash 29 means that 32 minus 29. So how many? 3 bits. So 3 bits you are borrowed from the host sections, that is the last sections. So 3 means what? That is 2 to the power of 3 is 8. So 8 host address. So that 8 host address you will be finding from where 8 address is showing slash 248. That means from 256 it is reduced by 8, so that is 248. Now similarly you go and you up to here 25. So 32 minus 25, 7. So 2 to the power of 7 is 128. So that is 128 you can able to see. So that means from 255 you are coming 256 you are coming to 128. So 128 is what? Your last host group. That is the 4th group in the IPv4 sections. The 4th is nothing but a host address. So that host address is showing 128. Now you come here. What it is showing? 255, 255, 255. Here it is showing how much? 128. So 128 is shown. Slash is how much? It is 25. So 25 it is a CIDR. So this is the CIDR 25 it is showing, and that represent what is the type of the address that you are going to use it for the representations of the host ID as well as the network ID. So this is the very important sections you have to understand. That's why always you will find that the network layer in the university sets the questions in such a way that the numerical problems used to cover in this particular section. Only with a little interest, if you try to put your attention, these particular sections you can able to easily learn, and you can able to perform with an excellent scores. So that is what we try to see. So here once again I represent that to understand this slash. To understand this slash, you have to understand that this slash is giving an idea that how from the given 32 bit, how many bits you are using. Thereby you can able to from the host you are going to use it. Thereby you can able to say that okay, this is the network ID, this is the network combination of address or the host combination of address. So the 25 is a resemblance to this one. So all this thing is shown. Suppose if you are writing 8, so 32 minus 8, how much it is? 24. So you have to understand that 2 to the power of 24, what is the size? That is a very bigger size. So it is going to occupy the sections related to this. So that is what you can see here in the 32-bit. This was 255. 255 is nothing but all ones. As the number of we are borrowing one by one, so it is keep on adding. It is converting, putting as 0. That means when we are borrowing from the host, you are putting as zeros. But when you are taking from the network, you are putting it as a 1. So that's why everything is becoming 0, 0, 0, 0. So from the network, from the host, it is converting towards the network side. So that's how we are keep on the combinations with respect to subnetting scenario using this particular slash notations. And this is one of the compact representations of the subnet mask. There is another slide is there which I would like to show with respect to this subnetting scenario. Is you can try to see in this particular figure, it shows about a big single network. Another side it shows a division of a network with a 4 subnet mask. What exactly is this one? That we should try to understand in this particular. Now, as I have informed to you, is that basically subnetting, what is the actually, it is the process of dividing the single network into a multiple network. So you can see this is a one network, and you are divided into 4 different quadrants. So the subnet work, if you say, it is same as subnet. And subnetting where we are using for a classful addressing, like a class A, class B, class C. We are using this subnetting scenario. So in this diagram, you can observe that the big single network is transformed into 4 smaller subnetwork. Now, what is the advantage in this case is that when say this is a single house, and you are divided into small house, and you are giving everyone equal responsible for protection of the house, so it will be more secure. But here, if somebody enters it, they can able to access the entire space. So here it improves the security, and the maintenance and administrations in this case is very easy in this particular case. Now, one thing you should understand, that a subnetting ID is basically a unique ID in the network address, and a subnet ID is created based on borrowing bits from the host ID part. So that you have to also understand. So number of bit borrowed depends upon the subnetting creations. There are 2 types of a subnetting. One is a fixed length subnetting, another is a variable length subnetting. Fixed length means it is a classful. Because we define in this particular scenario is that okay, these are the bits that is going to use it for the class. So since it is clearly defined in the case of the subnetting, like a class A, class B, class C, you are having a range. Since that range is clearly defined, hence this particular class of addressing is suitable for the fixed length subnetting. Now, when we talk about a variable length subnetting, that is a variable length or a class full. In this particular scenario, we don't have any defined length, but it is having a flexibility of defining. As you know, in the class A, we are having in the IPv4, you are having a 32-bit. IPv6, you are having a 128-bit. So in the 32-bit, you have a network and a host ID. In the 32-bit, we use different methods to use that 128-bit. So there we don't have a class. That is a classless form of a subnetting. And here equal number of hosts we try to consider, whereas here we do not have any equal number of hosts. and the subnet will have the same subnet mask, whereas in this case subnet do not have the same subnet mask. That you see here. Now we go to the next slide with respect to this one. Now here you try to see an example. Now in this example a network is shown 200.1.2.0. Can you can you guess which class it is? So to understand this class, very simple is that you just remember class A is how much? It is 0 to 127. So that means 128 difference. What is class B? Class B starts from 128 and you have to add how much? 64. So it is 192. So you have to write 191. Class C 192. How much you have to add? 32. So it becomes 234. So you have to write only 224. So you have to write only 223. So if you see that range of class C, it starts from 192 to 223. So this is coming under class C scenario. So this is a class C network. Here you have to use for a subnetting condition. That means you are trying to create a two subnetting scenario. Now for a two subnetting scenario, what you are going to do, you are going to borrow the bit for the subnet ID. So you are going to borrow. From where you are going to borrow? You are going to borrow the bit from the last group, which is your host ID. This 3 is your network ID. So when you are taking here, you are taking a bit, so that is a 0 or 1. So 0 indicates the borrowed bit and 1 indicates also borrowed bit. So both are representing, one is representing the first subnet, another represents the second subnet. So in this particular scenario, you are having a 200.1.2. So remaining is what? 0, 0, 0, 0, 0, 0 up to 8 bits, 8 zeros. That is same as this 0. So this is a decimal. If you are putting in binary form, so you have to write 80. Now that is a 0. Now that is your 200.1.2.0. What is your next ID? That is your 1. That is your you are having a range 0.1.2.0, and the next one is nothing but 200.1.2.128, because this is your 1. So if it is if you are taking that host bit, that is a 7-bit. 7-bit you put as 0. Now if you are going with your 7th bit, if the 7th bit, if it is 1, so what is going to happen? It is 128, because your everything is 0. So here, from here you are taking 1 bit and you are creating that bit in the form of zeros and 1. So that's how it is going to produce the bit scenario as a 7th bit as 0. So in that case, it is going to show you the resultant decimal value as a 128. So you can see there is a 2 division is being shown here, 200.1.20 section here, and the next sections is with respect to 200.1.2.128. So this is how you try to define the your net subnetting case with respect to the net ID case, and this another case with respect to the host one subnet, another case with respect to the second subnet. Now we see the another scenario with respect to the 124 subnet. Now here, if you try to see the scenario, how this particular scenario is being shown with respect to the subnetting case. Now if you try to look across in this particular sections, or let us take the previous also. Now here one more thing I just want to you may be thinking that how this 128 has come. Now if you try to see the 8-bit, so the 8-bit instead of if you are taking the 8-bit, let us take the total 8-bit 000000, and here if you are putting a second case 100000, so it is 127, and in that case masking if you do all ones, then you get the case of 128, and when you do the masking in the previous case, except the first MSB, the remaining as ones, you get the same, or you keep the everything the same 1111, you will be getting the same value of the net result as 127. So that is what we see in the case with respect to the masking, subnetting and its masking. Now coming to this one, here you try to see we are taken into considerations 2 more bits. That means the previous case, here only the 1 bit is taken, but we are changing the position to 2 to the power of 1 means that is 2 possible, 0 or 1. Now here we are taking 2 bits, so 2 to the power of 2, 4 possible. So that's why you can see 4 different cases. So here also the same thing. If you start with the 0, so that is the first one. So you can try to see the next one. It is since it is a 0 and 1 scenario. So if it is a 0 and 1 scenario, you will be going with combinations with respect to 128. Then you are having a next. Sorry, your 0 is there. Then you are having a 64 is there. Then 128 and 122. This is how you can divide the single network, because you are having 00, 01, 10, 11. So you are having combinations about the first subnet, second subnet, third subnet, and the fourth subnet. So based on that combinations, you will be able to create the combinations of the 4 different subnetting situations. So that is what we have seen here. Now finally there is one more figure is being shown, where you only want to take into consideration is the borrowing from the net ID. When you are borrowing from the net ID, it is considered as 1. So here we and borrowing a bit in a step 2, that means you are taking a 2 bits from the host ID. So here if you try to see this one, 201.2.0, that is your address defined for this one. In this case here, since you have borrowed and you try to do the binary equivalent study of this one, you will find that it is having a 2 distributions with respect to 128 and 192. So here from here you will be having a out of this 8-bit host ID bit is a 6-bit, so the 2 to the power of 6 different 64 combinations you can able to create. So that is what you start from a 192, 128, 64 is nothing but 192. So you are having all the 64 combination across this particular case with respect to the host ID bits. Now there are some example that is being shown over here here with respect to this one. This example is very essential in the for you to understand, so that it will be giving a necessary understanding how to solve these problems. Now in the first example is shown a decimal dotted decimal notation is there. You have to convert to sorry, binary decimal is shown. It you have to convert to dotted decimal. So it is simple. You put it like this one, and based on that, whichever is one, you add it and you get it this one. That is how you can do. Second case, you have a decimal value and you have to convert to binary. So what is the best? You take this one like this one, or you divide, say 56, you divide by 2. It is since easily divisible, so it is 0. Again divisible 0 0 0, but 7 is not divisible by 2, so it is 1. 3 is not divisible by 2, it is 1. So finally 1 is the quotient. So that is how you can try to see, and you read from the right side to left, so you will get it as 1 1 1 0 0 0, and on the front side the 2 more 0. So that is how you get this binary equivalent. So that's how you can able to represent. So here there is a IP is shown like this one. Find the error. So any IP which is shown like this one, in this IP, what is the problem is that any IP which is showing a 0 in the starting in the in these sections, that shows that this is a wrong way of representations. So it should not have a starting zeros. No leading 0 should be there in 0 4 5. In this case, you can see that there are 5 different groups. So there cannot be a more than 4 members or 4 numbers, or 4 numbers are decimal. It is 5 numbers are shown. In this particular scenario, you can see it is showing 301. It cannot exceed more than 255. So that is wrong. In this case, you can see that it is a binary and a decimal. So you cannot have a mixture combinations like this. So this is example of this. Another example is shown. A block of address is granted for a small organizations, and we know that one of the address is represented like this: 205, 16, 34, like this one. And what is the block? So from this we try to create these notations, and that is a 32-bit, and from here we are going to subtract 32 minus n, that is the different combinations, because I have shown to you with respect to the previous slides, 32 minus n is nothing but a slash, so that is a 4-bit. So that 4-bit is you are turned to 0 here, and from that by turning to that particular 4-bit to 32, you get the front address. And if you are putting this one into 1, that is, you can see, you can get the forward address. So more about this one and the remaining example I will discuss in the next video series. Thank you.